So in this video we're going to look at the case where the power of the sine is odd and positive, and look at how we would integrate that. So for the guidelines for integrating powers of sine and cosine functions, which we saw in the previous video, this was scenario 1, where we have the power of the sine being odd and positive. We have an odd positive number here for the sine power. And the idea is we save one sine factor, and then we convert the remaining sine factors into cosines and use the Pythagorean identity. The key idea really is we're setting ourselves up for like a u substitution scenario. I'm gonna advance the slide. So same integral, but this way I have more space. So we start with the integral that we're working on. We're integrating the sine cubed of x cosine to the 5th power of x dx. And what you do is you save a sine function. So in other words, we look at this sine cubed as if it's a sine of x times the sine squared of x. So we still have the sine cubed. And this is times the cosine to the 5th power of x dx. And then we use the Pythagorean identity, cosine squared plus sine squared equals 1. And we solve it for the sine squared. So we get that the sine squared of x is equal to 1 minus the cosine squared of x. And then we're going to substitute the sine squared for or with the 1 minus the cosine squared. So I step down a line. We get the integral of the sine of x times 1 minus the cosine squared of x times the cosine to the 5th power of x dx. And so the idea here is if we were to make the u substitution, u equals the cosine of x, the derivative of the cosine is almost what's sitting here, because the derivative of the cosine is minus the sine. And so we're positioning ourselves to be able to make a u substitution. So if we clean this up just a hair, so I get sine x, and distribute this cosine into the parentheses, we get cosine to the 5th power of x minus cosine to the 7th power of x dx. There's a couple different approaches we could take. We could say let's do the u substitution. That would be one way to do this. Let's do a u substitution. We could also integrate this without doing a u substitution. So it's a little bit of a personal preference. So if I go u equals cosine of x, then I know that du dx is going to equal minus the sine of x. And so if we multiply both sides by the negative and multiply both sides by the dx, we get minus du equals sine x dx. We could even leave the negative on the other side if we wanted to, and say du is minus sine x dx, and all we would need to do is put a minus here and a minus here. We get negative times negative is positive, and then we get a direct u substitution. Minus sine x dx can be replaced with the du, and then we'd have u to the 5th and u to the 7th. So we could do a u substitution. We could also just distribute the minus sign into the parentheses. So we could get away with, most of the time if you can do a u substitution, you can also integrate it just by thinking carefully about what you're looking at. So right here, maybe a u substitution, depending. And then we distribute this piece in. We get plus sine x. I might even leave it in the minus form. Minus sine x times cosine to the 7th power of x dx. So here you could actually integrate it. Here's the minus sign without you doing a u substitution, by just saying, hey, I'm going to guess cosine to the 5th. When I integrate, the exponent's going to need to be 1 bigger, so cosine to the 6th minus cosine to the 8th plus my constant of integration, and then you just check. do you need to tweak anything? So if I took the derivative of this, what would I get? I would get 6 times the cosine of x to the 5th power, because we would reduce the exponent by 1, and then we would have to take the derivative of the cosine, which is minus sine, which is already sitting there. So the tweak would be to multiply this by a 6th, so that when you take the derivative, the 6 gets killed when it comes down. We reduce the exponent by 1 to get the 5. The derivative of the cosine is minus sine, which is already sitting there. And then same thing here, the 8 would come down when we take the derivative, so we would need to kill it. And then 8 minus 1 would be the 7. The derivative of the cosine by the chain rule would be minus the sine, and we're all good. So we could have done it without a u substitution. If you're not comfortable with that, you could certainly do a u substitution in this step. So we could get rid of this work, and we could say, hey, let's do a u substitution instead. So I get minus the antiderivative, and then we replace minus sine x dx with the du, which is going to leave us with doing a u substitution, u to the 5th, because u equals the cosine. So we would have u to the 5th minus u to the 7th du, and then we would integrate. We would get negative 1/6 u to the 6th power minus 1/8 u to the 8th power plus the constant of integration, and then we would just substitute our u back in, so our cosine x back in. So minus parentheses a 6th cosine to the 6th power of x minus an 8th cosine to the 8th power of x plus c. So this is one where u substitution will work, but because u substitution will work, we explicitly set ourselves up to be in that position. We could also kind of guess how to get that antiderivative without doing the u substitution, and you can play it out either way in practice.